Okay. All right, let's start the second part. So we just ended preliminaries. This is going to be the first thing that is officially on our syllabus. But again, it's going to be a lot of review. We're just going to talk about the equation of lines. So we're going to go over the formulas, make sure you know the formulas, make sure you know what all the pieces mean, and we'll do a few examples, and then show you some things on the calculator. But other than that, it's just going to be a big review of section 1.1, a line. So a line is a curve of no thickness that has constant steepness, basically. The steepness we would often call the slope or the gradient, mostly slope. And we define this guy, the slope, to be a ratio rise over run. Right? Because then it's easy to compare slopes. So I understand if I move, the run is the horizontal distance you would travel, the rise would be the vertical distance that you would travel. Let's say you travel a very high vertical distance in a very small horizontal distance, versus you can travel a very long horizontal distance versus, relatively speaking, a very small vertical distance. Then we would define this guy to be more steep than that guy. Right? So this is more steep. This is less steep. Now, to actually make something mathematical and make that exact in some way, we want to assign a numerical value to steepness. So because we can realize that things that are more steep just means you have a very large rise compared to a run, as opposed to not, then all we have to do is just give numerical values to these rise and runs, and then just take a ratio. The larger the ratio, the steeper we are. So that develops the idea of what we call a slope. Now, to actually come up with a formula for that slope, we put the points on a number line. So we put things on the Cartesian axes. Thanks to Descartes, who came up with the idea of the Cartesian axis, it has meant so much to mathematicians. So you can put the 2 points on Cartesian axes that's connected by a straight line that constant steepness, which means it doesn't get more steep and less steep in between the 2 points. It's always the same steepness. That's what creates a line. And so now we can start to plot values here, because now we have the xy axis, which has values built into the axes. So we can talk about this distance here, which is the run. We can talk about this distance here, which is the rise. And the run, clearly, from this measurement, if you're measuring a horizontal distance, you're going to take the right number minus the left number. So if this was a 5 and a 2, clearly the distance between those is 3, because 5 minus 2 is 3. So here, that distance is x2 minus x1, and that would be defined as the run. Similarly, you would define the rise as y2 minus y1, because if you're measuring a vertical distance, you take the top number minus the bottom number. And this gives us the first equation for slope. That's going to be rise over run, which is going to be y2 minus y1 over x1 minus x2. Customarily, traditionally, set slope equals the variable m. So this gives us the slope equation, right, which I believe I asked you on the quiz. So on the quiz, when I asked you find the equation for a slope, the answer to that was m equals y1 over y2 over x. So we visualize an object that has constant steepness. By using a ratio to describe steepness, we can develop this equation. Now, our goal is to find what would the actual formula for such a curve look like. So what we do now, fix one point, and allow the other point to vary, right? So i.e., you set x2, y2 equals to just xy. So now you have this object where one point is fixed, x1, y1, and the other point, xy, is allowed to slide along the line. So ultimately you can find all the points by just sliding this point to some location. And so that means, that gives us the following idea. Now if we want to find an equation that gives all the points on the line, all we have to do is let one of the points slide freely and figure out an equation that can track that point. But we already have an equation with the slope. So all we have to do is just go into this equation and replace the y2 with y, replace the x2 with x, and think of them as variables instead of constants. And so we get n is equal to y minus y1 over x minus x1, and then we can multiply both sides by x minus x1 to obtain this formula. And this is the first equation of a line. This is called the point-slope form for the equation of a line. That's called the point-slope form. It is so called because the information you would have at this point is the point on the line and the slope of the line. So it's called the point-slope form. So you would use, if you have a point and the slope. Now it turns out that sometimes knowing when your input is 0 is an important thing to know about. Graphically, this would mean that the curve would pass through the y-axis, and the point at which it does this is called the y-intercept. So sometimes we want the y-intercept to be considered. So this, the y-intercept, by definition, is where the line passes through the y-axis. And so that's your y, that's your x. This is called the y-intercept. Notice here that your x value will be 0. Also notice, therefore, that the coordinate must have 0 in the first thing, and we define it to have b in the second coordinate. So let's say the y-intercept is 0, b. So suppose y-intercept is 0, b. Then we can use our equation of a line here. If we set x1, the point that we care about, to be 0, b, we get y minus b is equal to m x minus 0. That's just mx, and then solve for y. We get y equals mx plus b. This is another important form for the equation of a line. It is called the slope-intercept form of the equation of a line. Why? Because you can use it if you know the y-intercept and the slope. Use you have the y-intercept in particular and the slope. Okay, so that's the equation of a line. That's the formula that gives you the slope. It's a measure of steepness of the line. We'll talk a lot about slope in this class. And these can be the equation of a line. They'll both be the equation of the same line. where m is the slope. X1 or Y1 can be any arbitrary point here. However, if you know the y-intercept, that we can call B, and we can plug that value in here. Other things, what about horizontal lines? These will show up all the time. So you should know how to deal with these. This is a line with no rise, i.e. rise equals 0. But that would mean by definition that your slope must be 0. So this is a line that would look like this, just passing through here, kind of through some point. So this is your x and this is your y. Now let's suppose this passes through some point k. The equation of that line is y equals k. So if you see y equals k, y equals 5, y equals 7, y equals 13, that is a horizontal line. And it comes about by setting m, we obtain this by setting m equals 0. The k would actually necessarily be equal to whatever the y-intercept is. But in general, if you see y equals a constant, this is a horizontal line. You should know that the slope is 0 for such a line. Similarly, you can have something called vertical lines. So this is a line, see that's the x and y axis. It moves exactly vertically. Right? Notice here that the run is 0 because you literally do not move horizontally at all. This means that your slope is undefined because we know we cannot divide by 0. Right? So if you want a line with no slope, it does not have the concept of a slope, this will be a vertical line. However, we need to be able to express an equation that describes these guys, so all we can do is just figure out where it touches the x-axis, and then just define that by the equation. So the equation for a vertical line will have the form x equals k. It will just be x always equals the same number. You should know that such an equation does not have a slope. It has an undefined slope, so m doesn't even factor in here. This leads to a summary, the sign of the slope, which you should know. So you have several cases here. You can have a line that behaves like this, moving up as you go from left to right. This line is one of positive slope, meaning if you calculate that ratio, you get a positive number. Another option is the line to go down as you move from left to right. This is a line with negative slope. If you calculate that ratio, you'll get a negative number. Again, there's a situation where you have a horizontal line. Here's where your slope equals 0. There's also the situation where you have a vertical line. Here's where the slope is undefined. You want to know certain expressions that we might use to describe such things. This will be described as an increasing line. And in general, if you have a function moving up as you go from left to right, you say the function is increasing. This will be called a decreasing line. And in general, moving down as you go from left to right will be termed decreasing. This one, we didn't talk about non-increasing or non-decreasing. But it's much more common to just call it the name horizontal, or just call it constant. So when someone says, oh, it's a constant line, they're usually referring to a horizontal. And this is of course called a vertical. So you can be increasing or decreasing, you can be constant, or you can be vertical. Exertions. Another thing now. Last time I taught this, I proved it, but I think it just ended up confusing people, so let's not prove it. We want to talk about perpendicular lines and the relationship between their slopes. And this is simply the definition of perpendicular means two lines are perpendicular if they meet at right angles. A right angle is just one that measures 90 degrees. However, 2 radians. So once you have your two lines doing their thing, but they meet at a right angle, we define those to be perpendicular lines. That is the name we give to them. And now it turns out that there's a theorem you can actually prove this, but I'm not going to. I'm just going to tell you. Two lines are perpendicular if one is vertical and the other is horizontal. Or two, the product of their slopes is -1. Now to prove that requires some geometrical thinking. I'm not going to do it, but that is what it ends up being. The product of their slopes is -1. So part 2 of that theorem can be described by an equation. So you can have either m1 times m2 is equal to -1, or you can think of it as one slope is the negative reciprocal of the other slope, where m1 is slope of the first line. First is relative, it doesn't matter who you choose to be first. And m2 is the slope of the second line. So if you have two lines, you measure their slopes. When you multiply their slopes, you get -1 as the answer. Turns out that those two lines will meet at right angles if you decided to graph them. One other thing you need to know about lines, you need to know about what we call parallel lines. These are lines that either never meet, kind of sad, or always meet. And in general, this is also a thing. You can actually prove this, actually. Even though it's kind of obvious, at some point we have to prove it. Two lines are parallel if they have the same slope. Where both slopes are undefined. any two vertical lines are parallel, as well as in all of the cases, any two lines with the same m value, they will both be parallel. So this means, i.e., m1 equals m2. M1 is slope of one line. M2 is slope of the other. For everything about lines that you want to know. Okay, we did all that, we did all that. And in the handout online, I gave you a lot of pictures for everything. And told you about that, told you about that. Okay, now I'll give you some examples. So there were problems like this on the quiz. Let's make sure that everyone knows how to do them. And I'll also show you more calculator and stuff here as well. 1. Find the equation of the line. That moves through the points -1, 2, and 3, 2. Find the equation of the line. Passes through -2, 3, and it A has slope 2, or B in another scenario is horizontal, or C it is vertical, D is perpendicular to this other line. E is parallel to this other line. So you guys can help me with this one to make sure that you're all not falling asleep. A, how do we do that? What did you do first thing? Find the slope formula. So m would be y2 minus y1 over x2 minus x1. This point, that's what you should be able to say in your sleep. And it doesn't matter who you pick to be x1, y1 or x2, y2. So I just label the first one x1, y1, the second one x2, y2. It doesn't matter at all. And so that would give us here 4 minus 2 over 3 minus a minus 1. Be careful of the parentheses here. So that would give you 2 over 4, which is 1/2. Now that you have that, what do you do? I would use the point slope form because now I know a point and the slope. So I'm going to use y minus y1 equals m x minus x1. And again, it doesn't matter which point you choose to put here. You can choose the one that you already labeled x1, y1, or you can even choose the point that you labeled x2, y2. It's not going to matter.
Wait, so we can use y
They're both describing the same thing. You can use any one you want. So in most situations, I think this is actually easier to use, but you can do whatever you want. So here I subtract that y value, put the m value, x subtracting so I'm using the -1, 2, so that would be +1, and that is the equation of the line. Now, unless you're specifically asked to solve for y and put it in a certain form, I'd be fine with that. If your answer choice has it in the slope-intercept form, you should know how to, if necessary, You should know how to put it in slope-intercept form. So in this case, you would solve for y. This would be 1/2 x plus 1 plus 2, 1/2 x plus 1/2 plus 2, would be 1/2 x plus 5 over 2. You should know how to go between 1 and 2. Okay, problem 2a. How would you do that?
So you would y equals to, I would use, so y equals to mx plus b, and you plug in negative 2 to x, and the slope is 2, so I have to plug in 2 for m.
So for
And-
m, you were told the slope was 2,
Mm-hmm.
okay?
And
Then?
since it's given the point, like negative 2 comma 3, I would plug in 3 for y. 3 equals to 2. 2 times negative 2 plus b.
Okay.
And I'll get 3 equals to negative 4 plus b, and b equals to negative 1.
B equals 2,
I mean, not negative 1, 7.
okay? Then?
Then I would do, so it would be, so the equation would be 2x plus 7? I don't know.
That's not an equation.
Y equals 2x plus 2.
The equation must have an equal sign. Or you can just do y minus y1 equals mx minus x1. That would be the answer. What about B, horizontal? Right, y equals 3. Because horizontal means it always has the same y value. This point tells you that the y value it passes through is 3. So there's nothing else to say here. So if you do B for horizontal, y equals 3. What about vertical? X equals negative 2. Really nothing to show there. What about perpendicular to that path?
Rewrite it as the slope intercept.
Okay, so you want to rewrite the 2x plus 3y equals 7. You don't have to do a complete rewrite, just kind of start solving for y. 3y would be minus 2x plus 7. But you can kind of see in your head that that would be a minus 2 over 3, but clearly it's not terribly complicated to do this here. Okay, so now what? So you take the negative reciprocal, so you are going to set your m to be the negative of that flipped. So that's just positive 3 over 2 is what you're going to take for the m value.
How'd you get negative 7?
Positive 7. I divided both sides by 3. So now we would have y minus y1 equals m x minus x. And so that's y minus y1 is equal to m, which I know is 3 over 2, x minus x1.
All you did was you just took the reciprocal?
Negative reciprocal. So I flipped it and changed the sign. So the 2/3 becomes 3/2, and then I change the sign.
Whenever it's a negative fraction, you do that?
No, in general, whenever it's perpendicular, you do that. It's always going to be the case that your m1 is minus 1 over m2. Flip it and take the negative sign.
So if it was positive, It would become
If
negative.
this was a positive, you would make this one negative, yes. What if you wanted it parallel to that line? The same slope. So here you know that this guy had slope. We already saw for this, so let's not just do that. That was minus 2/3. So here we would set m equals exactly that, minus 2/3. So y minus y1 equals m x minus x1. That's how. Let's look at how to graph straight lines. Again, not terribly complicated, but sometimes things make this more complicated than it has to be. Sometimes I see kids trying to draw lines and they're like plotting 7 points. The thing with straight lines is that they're easy to graph. You only need 2 points. If you're plotting more than 2 points, you're wasting your time. You just need 2 points on a line and then draw a straight line through those 2 points. Usually the best 2 points to find are the x and y intercepts. But there might be a case where you need something other than those. But those are the first ones you would try to find. So graphically. Graphing straight lines. You only need 2 points. Waste your time with more. So you only need 2 points. Usually, not always, but usually, x-intercept and y-intercept are easiest to use. So let's do some examples here. I want you to sketch the following. 2x plus 3y equals 6. B. Y equals minus 1/2. X plus 3. C. Y equals 1. X equals minus 3. Those are the 2 points at most. Don't go beyond that. Okay, so the first one, how would you sketch it? How? What would you do here?
Set, if you're looking for the x,
Yeah.
set y to
Exactly. So if you plug in y equals 0, this would mean, so cover that up, solve for x, x equals 3. And you plot that on here. Then if you try x equals 0, that would mean, you cover that up, solve for y, you get y equals 2. Put that over here, and then draw a straight line through that. Done. What about if I had y equals minus 1/2 x plus 3? I'd kind of do the same thing. If I plug in x equals 0, you get y equals 3. Plug in y equals 0. Now you have to solve for x. X would be minus 3. You have minus 1/2, x equals minus 3, which means that your x would be positive 6. So 3 and 6. C. Sketch Well, that you know is horizontal, so you don't even need 2 points here, really. So you should recognize that that's the equation for a horizontal line. So you just draw your xy axis, and just draw a horizontal line passing through y equals 1. X equals -3. That you should know is vertical. So you don't even need any points. You don't need 2 points, you only need 1. So just find where x is -3 and draw a vertical line through that. And that's it, you sketch the lines. That's it. Let's look at, that was 1.1, that's there, so nothing too crazy there. Let's look at how to do this on the calculator. So I'm going to show you on your calculator now how to actually graph a line, or in theory how to graph anything else. So you guys should always bring your calculators. Even if you don't get to use it in a quiz, sometimes I'll show you things in class, and I actually want you guys to follow along on your calculator. It happens all the time where students go, how do you do that on the calculator again? I'm like, I can't tell you, you're in a test, you should have practiced. So you should try to get some practice in. Second time's the charm of this. So you should try to get some practice in, at least in the class. Calculator tips section. First step is to turn your calculator on. So solving equations, expanding, we know all that. Let's actually look at how to actually sketch something. So that's what we want to look at here. So let's suppose we want to sketch one of these lines. Let's say you wanted to sketch the second one. So when you're going to sketch a line or a curve in general, what you want to do first is you want to actually solve for the dependent variable. So you'd solve for y. Okay. So let's say in part B we solved for y, and we got y equals, I forgot what we put, y equals -1/2 plus 3. Okay? So to actually graph that, you go to what I'm going to refer to as the y window. You'll notice here in green above the F1 button, there is a y equals kind of thing. Once you see something written in green, it means to access that command, you need to first press the green diamond button. Anything written in yellow, to access that command, you need to press the yellow second button. Things in purple, you need to press the purple button to access them. You get the idea. Okay, so y equals is in green. You need to get to that window whenever you want to graph something. So what I'm going to do is I'm going to press the green button, press the F1 key. That would bring me to what we call the y window. So you can try that. Press the green button, press F1. Now we're in the y window. You'll notice that we already have a function here. For our purposes, we don't want that to be there. So if you have anything in your calculator, you can clear it. Just move up and clear it. Okay. So now you would actually enter the equation in there. Okay. And we're going to graph that. Now you should be aware. Oh, was there a question?
When you graph, which button do I've tried learning how to use this, I still didn't know how to do this.
Yeah, I'm in the middle of showing you how. Just keep paying attention. You go to the y window by pressing the green, pressing the y equals, you will enter here. You are going to enter the equation of the thing you want to graph in that line. Okay, so let's say I wanted to graph that second example that we did, y equals minus 1/2 x plus 3. I'm going to enter here minus 1/2 x plus 3. So if you're looking at minus 1/2, you need to press this minus button, not that minus button. There's a difference between the two. This you use when you're subtracting two things. This comes up all the time, so I'm stopping to tell you. This is used when you're subtracting two things. You're taking 1 minus 3. You would enter this minus sign. If you want to enter a negative number, like you want to enter -5 as a value by itself, use this number. It negates the answer. Okay, so I'm going to enter minus 1/2 minus 1 over 2 times x plus 3. Okay. So now you have that is entered here. Now, this is where it gets tricky. So everyone pay attention. We're going to simply press the graph button. And that graphs it. Okay? So if you look over F3 in green, you will see something that says graph. You're going to press the green button in order to access that. So once you enter your y function, press the green button, press graph. Enter the green, and that's how you graph the function. Yep. So that's it. That's how you graph a function. If you're ever in a situation where you need to graph a function and you don't want to do it by hand, that's how you would do it. So you first go to the y window, green button, y, enter the function you want to graph, and then green button, graph. You'll draw a picture. You should know if for some reason you're not seeing clearly enough what you want to see, you can actually change the window, zoom in or zoom out by going to the window button. Okay? So in the window button, you can set the parameters that you want. So for example, let's say I wanted a nicer view. I can go green, window button, and I can set what my minimum value on the x-axis is versus the maximum, and etc. Okay? So let's say I wanted to zoom in a little. I don't want to see much of the negative side, so let's put that to say -1 for argument's sake. Okay. So I can set this to be -1. Let the max still go to 10. Let's say I want the y minimum to also be -1. And let the y, the upper y, the y-intercept was 3, right? Let's make this like a 4. So let's make y maximum like a 4, right? Now it's worth mentioning the XSC1 and the YSC1. Those stands for the X scale and the Y scale. What that tells the calculator is that's the notches on the X and Y axis. It will count by 1, right? So on the X axis it will be 1, 2, 3, 4. If you set that equal to 2, for example, it will go 2, 4, 6, 8, right? And it will, that's telling you the scale that it's using on the axes themselves. This here is to set the resolution. Usually you don't have to mess with that. Resolution of 2 is going to be fine most of the time, but you can actually increase the resolution if you want a crisper picture. We're never going to need that. But you can use the X min and max and the Y min and max to set the axes. And once you set those, you can again just go straight back to the graph window, and you'll notice that the view changed, right? You zoomed in a lot more just now. So that's basically how you graph something. Enter it into the, so you, obviously first you have to solve for y, so you get y equals some function of x. Go to the y window, enter that function of x, green button, F3, will graph it. If you need to shift the window, green button, window, set your axes, the axis parameters as you want them, and then go green button, graph again, and it will change the view. Yeah, and that's basically it. Any questions? Did everyone try it on their calculator, and if there are any issues, we can troubleshoot them now. So those commands aren't terribly complicated. Wait till we get to regression. We'll be going all over the place. So you do want to practice using your calculator. Did you?
Oh no.
Okay. Okay, so that's how you graph things.
What if we do need to reset something?
Like,
The calculate, how do we do that?
Like clear?
Clear,
well, in the event, hold on. So if you need, so this is, I'm going to show you this in the next section as well, but sometimes you can have interference. So let's say you go back to the Y window. If there are other things there at the same time, it will actually graph both of them. So let's say this is x, enter, let's say in y3 we have 2 minus x squared, enter. If you go to the graph window, it'll literally be drawing all these guys at the same time, right? And that can, of course, you might not want those. So to clear any information that's already in this tool, you simply clear it at the Y window. So if you go to the Y window, you don't want any of these guys, you just move to them with the arrow keys, and you can just clear them. You can clear them. When it comes to storing values in any variables, you can do a different clearing function. Let's say we go back home. You'll see F6 is cleanup. You can actually access F6 by here. Notice it's written in yellow. Second function F1 brings to F6, and you can clear all your variables, clear this, restore custom default, whatever. Right? So in the specific tool you're using, you can literally use the clear button to clear out information you don't want. If you want to do like a system-wide clean, you can just do an F6 to clear everyone at the same time. In terms of, let's say I saved a value in A and I want to save another value in A, you should also know that the calculator just overrides values. It will just take the previous value. So let's say I save A to have value 2. Later on I save A to be value 3. The calculator is just going to remember A equals 3. It's going to forget the 2. It will always remember the last saved value. So sometimes going through the trouble of clearing things, it doesn't even matter, because once you save something in your current set of calculations, that's the one the calculator is going to remember. It's going to forget all the previous set. It will forget it automatically. But yeah, clearing, you can use the clear key in the specific section that you want to clear, or you can do an F6 to clear everyone. Yes?
If, for example, the calculator graphed all the lines you wanted on the thing,
Mm-hmm.
like all the Y's, will it tell you which line it was?
No.
Which specific line?
No. The best you can see there is that it'll graph them in the order in which you listed them. So I don't know if you noticed this, but when I pressed enter on the last section, it drew the straight line first, then it drew the other straight line, and then it drew the parabola. It'll literally graph in the order in which you're doing. There are situations in which you'd want to graph several things at a time, but we'll talk about that in the next section, where you want to graph things like piecewise graphs. That one's a little more complicated because you have to set the restrictions that you want. But as for just graphing a regular thing, that's how you do it. Any other questions? And that completes section 1.1. So I'll post the MATLAB homework for this due next week. My MATLAB. And we will move on to section 2, where we'll talk a little bit more about lines. We're going to talk about applications of lines. Now, a lot of our applications in this class are going to be business-based, so we'll talk about computing things that have to do with revenue and profit and depreciation and things like that. So we are going to look at some of those applications here. But there is a kind of general theory as well in using lines to model certain situations. So if you have a certain word problem, sometimes setting up the equation of a line is the best way to attack that word problem. You need to be able to recognize when you're in such a situation. So for our purposes here, consider a linear equation to have pretty much y equals mx plus b, where we're considering these as constants, so this is the slope and this is the y-intercept. We're going to be putting interpretations on these, and both of these are constants. This guy is the independent variable. This guy's the dependent variable. Now there are some situations in which these guys will take on certain interpretations. And that's basically in the application sense, it's what we're going to talk about. So let's first talk about how we can interpret things like each of these numbers, and then we're going to talk about cost, break-even analysis, depreciation, and then I'll talk about piecewise graphs. And that will complete this section. So, last time in 1.1, it's just like 20 minutes ago, or 10 minutes ago, we looked at the equations of lines, and well, let's see how we can interpret slope. Here are some interpretations of slope. So I know a lot of the time we think of slope as the steepness of a line, which it is. There are other interpretations that we often want to apply to slope. Let me kind of segue into one here, illustration. Suppose we have an object moving at a constant rate of speed. And we're tracking its distance traveled. Okay, so it's moving at a constant rate of speed. It just so turns out that this will obtain a straight line. So let's say I'm measuring how far this object is traveling in regards to time in hours. And I'm tracking its distance in miles. Okay. So I'm tracking this object, it just keeps moving, it's not really speeding up or slowing down, it's just moving at a constant rate of speed. And let's say after some point, after tracking this thing for 3 hours, I know it ended up 150 miles away, which means that it looks like that when I'm tracking the distance. So here's a question or instruction. What is the slope here? What is the slope of this line? Huh? It's 50, right? So you do M, you want to do rise over run. So you can choose 2 points. This is 3, 150. You also have the point 0, 0. You can also do rise divided by run. It's just 150 divided by 3. But if you want to use the formula, it's going to be y2 minus y1 over x2 minus x1. You you would get 50. Here's another lesson. Interpret that number. What does that number mean here?
Total.
It's driving at 15 miles per hour.
15 miles per hour would be the interpretation. Because our y-axis is measuring units of miles. Our x-axis is time in hours. In other words, this ratio is, in its numerator, you are calculating units of miles. In the denominator, you're calculating units of hours. Which means this 50 is miles over hours or miles per hour. So in this case, your slope is 50 miles per hour, which means you can think of the slope here as what? A speed, or a velocity more specifically, or what we might call a rate of change. Right? Which is probably how, not a way that, especially people who have never done calculus before, it's probably not a way you would think of thinking of a slope. Right? People think of a slope, oh, it's steep. I know if it's positive, this means the line is doing this. If it's negative, it's doing that. If it's zero, it's horizontal. But another way of thinking of slope is as a speed. It tells you a rate of change. It tells you how fast the vertical axis, the quantity on the vertical axis is changing with respect to the quantity on the horizontal axis. That idea is not just a segue into the applications we're going to talk about, but that idea, that realization is responsible for half of calculus. That's half of calculus right there. Someone noticing, you know what, we can think of slope as speed. Calculus. Once someone actually, well, if we think of slope as speed, what does that mean? What are the consequences of that thought? The consequences are differential calculus. If you take that thought to the extreme, you get calculus. So it's a very profound thought to actually think of slope in this way. But it's an important way to think of slope in calculus in particular. What you can note here is there is nothing really special about our labeling. You can think of, sure, you can think of the vertical as miles and hours, but did we have to label it that? Couldn't we apply the same kind of reasoning whether I labeled this something else? Like, what if I labeled it profit and labeled this price? Or what if I labeled this size of tumor versus amount of chemo? Or a bit of a morbid example, you know. But yeah, you could have labeled the axes kind of anything you want, but this interpretation would kind of always be there. The slope of that picture is going to tell you how fast is the vertical thing changing in relation to the horizontal thing. It is going to give you a speed. So it's a rate of change. So to say that the slope of this graph is 50, another way you can think of what I'm saying is the following. Every time the hour moves by 1, the distance will move by 50. In other words, the distance axis is increasing 50 times faster than the horizontal axis, right? I can think of it that way. Right, so the slope is kind of a measure of how fast this thing is moving compared to that thing. And that idea is what we call a rate of change. Okay, so that's kind of a buzzword in calculus. So that leads us to the interpretation of slope. A measure of the speed of a quantity at which a quantity is changing. you can think of it as how fast is the y value changing in relation to the x value. Another very common way to say changing in relation to, this is, sometimes we might use the phrase with respect to, which we might abbreviate as WRT. So if you see me write that, I mean with respect to. Right? This just means you're comparing these two quantities and you're seeing how this thing is behaving in relation to that thing. Right? You can also think of how the y value changes in response to unit changes in the x value. And again, remember, yx can represent anything. Meaning the meaning of your graph can be changed by your labeling. So you can think of x and y can be any two quantities that you're measuring that you want to compare to each other. And one way to think about the slope of such a picture or a graph is to think about, oh, it's telling me how fast one thing is changing in relation to another. And in that case, the sign of a slope, I mentioned this earlier, the sign of the slope would be similarly interpreted as something I mentioned earlier. Interpreted as earlier. In the sense that if I measure the slope of some graph and I'm trying to figure out how one thing is changing with respect to the other thing, a positive slope will tell me that something is increasing or getting bigger. While a negative slope will tell me something is decreasing or getting smaller. So regardless of what this thing looks like, or what we're labeling it, if I realize whatever picture comes here has a negative slope, what that means is that when the price is getting bigger, this is getting smaller. If it has a positive slope, it means that when this gets bigger, that's getting bigger. Right? The actual value of the slope tells you how far or how many, what in proportionally, how much bigger is this compared to that, but the sign will tell you, is it actually getting bigger or smaller? So that's important. So there are several ways you can interpret slope like that. And once you start applying those interpretations, applying this interpretation in particular gives you calculus. But we can apply any number of these interpretations and they will mean something else to us. So now let's talk about modeling, in particular modeling with equations. Modeling. So once you look at some scenario or situation in the real world and you decide, I want to describe this using an equation, or using a formula, or using a graph. Once you start to use anything mathematical to describe some situation, you say you've created a model. Now, when a straight line is the best model to use, we say say we've created a linear model. The next question should be, how do I know when a straight line is the best thing to use? And once you know a straight line is the best thing to use, this will tell you how you want to think about the slope of that line. Or should be. Should. So a lot of times when you want to set up a model, you will be setting up some scenario situation which is going to just be described to you, usually in a word problem or in words. So you need to go from the situation where you're in a word problem to a situation where you have an equation that you can solve. We looked at how to solve equations. So sometimes you have to go from a situation of being in a bunch of words, translating those words to equations, solving the equations, and then you can solve whatever problem that the original equation happens to be solved. So sometimes a straight line is going to be the way to do this. How do you know when the equation you should try to set up should be a straight line? The first way is you're told. Right? Sometime a problem will specifically say, use a linear model. Consider this as a linear relationship. Consider one thing to be directly proportional to the other. Blah, 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 etc. You will actually be told. So you'll see words like linear or linear relationship. Or you'll see something like directly proportional to. Etc. in the problem. Now once you see sort of those key words, you kind of know, okay, I should be thinking of a straight line. Right? So sometimes the problem will specifically say, use a linear model. There's another situation, because sometimes the situation is not going to tell you to use a linear model. Sometimes it's just going to describe a situation to you and you have to figure out it's a linear model, and here's how you know. The quantity you're measuring. Is changing. And changing here is changing in general. It could be increasing or decreasing by a fixed absolute amount. At regular intervals. So fixed absolute amount means I'm talking about a certain magnitude, right? One of the first contrasts would be, which we won't really talk about exponential models here, but one of the first contrasts would be if this were a relative amount. So if someone tells you, for example, this thing is increasing by 2 units every month, that's a straight line problem. If someone says, this is increasing by 2% every month, it's not a straight line problem anymore. That one little word completely changes the interpretation, right? Because 2% is relative. 2% of a bigger thing is bigger, right? But if you just say it's 2 units, that's not relative. 2 means the same thing in regards to this object, right? So you have a fixed absolute amount. So if you know something is increasing or decreasing by the same value all the time at regular intervals, that's a linear model, right? Anything that is described to you in that way, you should use a straight line to describe it. So let's use, so we talk about some specific examples here, although there will be others. The first one is linear cost. us. Meaning, problems of this type will very typically show up on a final exam and exam for us. The first one is linear cost. This model says your cost is equal to a line. So it's something like cost per item, number of items. This is called the overhead. Now this is usually your variable. There's going to be an X. Okay? So you'll often see this represented as cost is equal to some cost per item times X plus overhead. So if you're looking at your cost in some situation, one way in which this can come to you is that if you can actually measure the cost that it costs you to make X items, right? So it might cost you $20 to make 50 things, so that's going to be the cost from that. The overhead is the cost you have to pay no matter what. So you could be manufacturing something, but overhead would be like the cost of renting the space, right? Whether or not you manufacture stuff, you still have to be paying the rent. You still have to be paying employees' salaries. You still have to be doing a bunch of things. Any cost that we call fixed costs, that's another way to call this, fixed costs, meaning these are costs that you pay no matter what. That's called your overhead. Then you can have other costs associated with you particularly making your product or providing a service. Okay? So this is a very, it's a simple cost model, but it is often, it shows up all the time, where your cost can be calculated by, there's a bunch of costs that you just have to pay no matter what. Those are usually around the same items. And then there are costs that have to do with you doing business. The more business you do, you might have more costs per item. So that's a very important model. It's the linear cost model. So now, we can do an example of this. So there's a word problem here that we're going to go through. We're going to use the linear cost model to help us solve it. I'm not going to write out the word problem, as you can see. I'll probably read it to you guys. Oh, by the way, small FYI here. The slope here may be referred to as the marginal cost. Now we will cover marginal functions specifically, so you'll get more of a sense of what that means. But just here I can just tell you that when you talk about the slope, that cost per item, sometimes that's called the marginal cost. So let's do our first example here, where we're going to apply a linear cost model. Okay, so, and the more we learn, the more I add to this example, but the first part of the example is the following. Okay, so besides teaching, Javon sells lemonade at a lemonade stand to make ends meet. He bought the stand for which he makes fixed weekly payments of $100. It cost him $1.50 to make each cup of lemonade. That C represents the cost per week for Javon to produce X cups of lemonade. Okay. So let's write down some of that information. example. So, this is the example of Javon's lemonade stand. Okay. What we know is, we can talk about the costs. So we have weekly payments here of $100 for the lemonade stand. And we also have, it costs us $1.50 per cup of, to make a cup of lemonade, right? So to find the ingredients and to pay for the cups, on average it works out to $1.50 per cup. So now I want the function c of x to represent the weekly cost of making x cups of lemonade. So in reading this problem, you should notice two things. One, there is a fixed cost, i.e., for what I'm paying back for the lemonade stand. That $100 I have to pay whether or not I make lemonade, whether or not I sell lemonade, or whatever, right? I have this card in my possession, I need to be making these payments of $100. There's another cost that is now associated with the business. Now, I'm paying these $100 every week no matter what, but to actually make a cup of lemonade, for each cup it's costing me $1.50 to actually make that cup, right? So the items I'm making are cups of lemonades, and it's costing me $1.50 for each cup of lemonade. So now, you can understand, so here, we can use a linear cost model. Because this tells you that's a linear cost model. Cost per cup is a fixed value. So cost per item is constant, it's fixed. The moment that is not the case, a straight line would not be what we'd want to use. So my function c should look like cost per item times x cups of lemonade plus the overhead. So what would my function be here?
1.5
C equals 1.5
x plus 100.
is plus 100. That is the answer. That's part A. I actually did part C. Part A asks two questions. A was, what is Javon's overhead? And that was $100. I just said that in parts B. And this is cost per cup, not including overhead. And that was $1.50. And in C, I asked you to find the total cost function. And that was what we just found. So once you find the overhead, that's going to be like the y-intercept. It's going to be the guy over here. And once you find the cost per item, you're going to that's going to be the slope of the straight line. Notice here, when x is 0, that cost remains because that's a fixed cost. It's also going to be your initial cost. You can think of it as MD. How much does it cost Javon to make 50 cups of lemonade per week? Oh, how would you figure that out? You put what?
Okay, now.
plug in 50 for X, right? So this says 50 cups of lemonade. We know what's measuring the number of cups is the X. So they just told you the X value, and obviously they want you to find the C value. So here you would set X equals 50. This means your C would be 1.5 times 50 plus 100. And what's that? 75? So 175. That's the weekly cost. E. Let's say Jawan has $250 to put in his lemonade stand business this week. How many cups of lemonade can he make? We have 250. How many cups can you made this week? That's the C, right? That's the money that we have. So that's your cost. So this means you just said 250 equals 1.5x plus 100, which means 1.5x is going to be 150, which means 150 over 1.5, which means this is 1500 over 15. So we could make 100 cups of that. And we'll stop there. So we're still in the middle of 1.2. We've completed 1.1. I'll put up the homework for that. Be sure to print out the handouts ahead of class, start trying to read through them, try some of the examples maybe, and we'll continue next time. Maybe even try to print out the regression handout, try some of the calculations.
I don't think it's possible.
I didn't put it up yet? I will put it up.
Okay.
Yes.
For my math lab, I just ordered it, and it's, if for some reason it's shipping the access code by mail,
Yes.
so it has.
You should have, I think, 2 weeks access in the meantime. You should have temporary access.
Yeah, because it's not letting me access anything like the classroom. They didn't give me, just said that it was shipping something, so I can't do
Well, you can get to it directly through Blackboard, but if you don't have the class code, I can give that to you.
Okay, because I tried the class code too, and it didn't work.
You tried my class code? Do you know the class code?
Yeah, the Harley 457.
Well, I don't know why that's not working. I would go to the SAC Center and ask them to help you set it. Because if you paid for it, you should have like a temporary access for like 2 weeks or so until it comes in. I don't know, to troubleshoot that, try to talk to the SAC people. Okay. Any other questions? Okay. I guess I will see you guys next week. Remember you have the tutorial section next time. At 1:15. When does it start? 1:15? Yeah.
Every week.
Yeah. I'll leave some blanks here. You can ask her to go through the quizzes with you guys if you want. I believe so, yeah. But I'm gonna make sure that 1.1 is set for next week. Oh, let me turn this. I do take attendance in general. Today I'll probably use the quiz to do it. So if you filled out your name on the quiz, I'll use that.